I'm Manfred Schmitz, and I'm the CTO of MEN Microelectronic. We design and produce electronics for mission-critical applications in Nuremberg. Mission-critical computers are used whenever they really have to work reliably, for example in trains or airplanes. The basic idea behind the industry standard of CompactPCI was to harden PC technology for use in industrial areas. Every PC has serial buses like SATA, Ethernet, or PCI Express. The basic idea is still the same. We want to transfer widespread, inexpensive, and proven technology to modular computers, and have defined a standard that is based on exactly these serial protocols. We call this standard CompactPCI Serial. To benefit from state-of-the-art technology, you need to extend CompactPCI. Our intention was to make use of the serial buses in the modular computer. We simply wanted to transfer existing technology to the mission-critical environment. I'm Matthias Beer, and I'm the head of product management at MEN. With my roots in hardware design, I started as a developer at MEN, then became a project leader and have managed many CompactPCI-based railway projects. CompactPCI today is mainly used in industrial markets, as well as in the shipbuilding, automotive, and railway industries. It is used for vehicle control, for wayside communication and visualization in control centers, or on-train internet.
Technik eingesetzt, Visualisierungen in Stellwerken. Auch hier wird CompactPCI eingesetzt.
The difference between the old parallel CompactPCI and the new CompactPCI serial is in the bus connection. Formerly, we had a parallel bus. Now we have dedicated serial connections between the individual boards. Bandwidth is limited only by the bandwidth of a serial protocol. CompactPCI Serial is the first standard that lets you build up multi-processing systems in a reasonable way. A huge advantage compared to CompactPCI is that you don't need any special CPUs to do this. You can also build RAID systems quite easily. RAID means that you mirror or double capacities to set up large drives, which lets you master failure safety inside the vehicle. CompactPCI Serial has a classic star architecture with the CPU at the center and peripheral boards surrounding it. Every peripheral board in the system is wired to any other peripheral board using a special Ethernet point-to-point connection. When I want to build up a multi-processing system with many CPU boards, every CPU board can communicate with any other without using things like a central switch. If you go on thinking about the idea of a multi-processing architecture, you can easily combine several of these systems to build a supercomputer. There are already many high-performance supercomputers in use worldwide. MEN technology lets you achieve the same performance with fewer system racks and with only 10% of the power consumption. With CompactPCI Serial, you have the CPU and the peripheral cards communicating directly. All you need is a passive backplane. You don't need further electronics. Other standards often specify a complex special backplane, or even switches that add to the cost of the system. You can easily build up systems using standard parts. The backplanes and software are all standard. A typical system could be a CompactPCI serial CPU that drives 7 graphics cards. These graphics cards occupy the CPU's neighboring slots, communicate via PCI Express, and can control up to 28 screens. Just imagine the video walls that you can create like this, and all this with just one CPU and standard software. Another main application for CompactPCI is inside trains, to provide wireless service for communication between the train and the wayside. Behind me you can see the system used in many German ICE trains. It allows access to train data from a remote control center using wireless interfaces like WLAN, GSM, or UMTS.
GSM, UMTS in den Zug greifen.
The mobile integration platform on our ICE train is the central unit that takes care of train-to-wayside communication and is used in all long-distance vehicles of Deutsche Bahn. It transfers data from train to wayside and from wayside to train. It uses all mobile networks such as wireless LAN, GSM, or GSM-R networks.
Diese wireless interfaces löst man über Karten wie diese.
The wireless interfaces are implemented by these modules, which are carrier cards for modem solutions, where the modems are plugged into the carrier cards. They are connected via PCI Express and USB. SIM cards are necessary for UMTS as well, so SIM card holders are also provided. Antenna signals are led to the front and then connected to the train antenna. Well, the requirements for the MIP as a subsystem in a train are mainly the fulfillment of railway demands, reliability, and longevity. That's essential for railway traffic in particular. CompactPCI is made for building systems that really work, that is, in mission-critical applications.
Eine typische Architektur für sicherheitskritische Interlocking-Systeme sieht wie folgt aus.
A typical architecture for mission-critical interlocking systems looks like this. There are several CPUs, all doing the same thing. A majority vote decides whether a computation result is correct. 3 CPUs are used whenever you want to be safe and available. That means that all 3 computers do the same thing. If they come to the same conclusion, everything is fine. But even if 2 computers agree, the result is validated. A typical application for this would be a railway control center. Here, systems have to be not only safe, but also available. If a system like this fails, the trains would stop and the railway control center wouldn't be operable anymore. Another application example is a control system for collision avoidance in airplanes. The unit is made up of 4 CPU modules which communicate via gigabit Ethernet via the backplane. Cameras are connected to 3 of them. The CPUs compress and analyze these video data and send them to the 4th CPU in the system. This is how a collision can be avoided.
Kann somit beitragen, die Kollision im Flugzeug zu vermeiden. Unsere Kunden verwenden CompactPCI-Systeme auch auf der Schiffsbrücke.
CompactPCI systems are also used on ship bridges, where there are increased temperatures and higher shock and vibration demands. Therefore, we had to equip our CPU module with a significantly bigger heat sink. Extension cards are also possible. For example, a quad Ethernet extension, a double CAN extension, or serial interfaces.
Oder zweifach CAN-Erweiterung oder eben serielle Schnittstellen.
CompactPCI und auch CompactPCI Serial ist ganz speziell gemacht, damit man sie in
CompactPCI and CompactPCI Serial are especially made for rugged environments and mission-critical applications. The backplane has been adjusted and the front panel is very stable. When used in conductive cooling enclosures, every board is fitted into a metal box and is self-cooled via the aluminum frame. We have our own in-house test laboratory where we simulate temperature, shock, vibrations, and electromagnetic fields.
Vibrationen, auch elektromagnetische Felder werden simuliert.
The components we use are all specified for -40 to +85 degrees Celsius or even more. The original parallel CompactPCI was standardized by an organization in the USA called PICMIG, and MEN headed this workgroup. CompactPCI Serial was ratified in 2011, and the standard that combines both, CompactPCI plus I/O, in 2010.
die Spezifikationsgruppe gegangen und der Standard, der beide verbindet, also CompactPCI Plus I/O, wurde 2010 ratifiziert. Wie wir CompactPCI Serial definiert haben, haben wir uns schon überlegt.
When we defined CompactPCI Serial, we already thought about how we could continue using the existing boards. And then we had the idea to put a standard in between, which supports both, a parallel and a serial bus. We call this standard CompactPCI Plus I/O. It's a CompactPCI standard that already supports some serial signals. The idea is you can mix parallel and serial systems.
Im neuen CompactPCI Serial Standard benutzen. Man kann sie mischen, das ist die Idee dabei.
Ein typisches Hybridsystem besteht aus mehreren Teilen.
A usual hybrid system has parallel as well as serial components. We use a monolithic backplane to connect all of these parallel and serial buses in one design. Everything is controlled by the CompactPCI Plus I/O CPU, the heart of the system.
CPU, die das Zentrum dieses Systems bildet.
For today's applications, CompactPCI Serial is already recommended for video recording systems with very high storage capacity and for RAID systems, but also for multiple graphics systems, wherever a high data rate is necessary. Think of performance, high storage capacity, or multiprocessor solutions.
Erachten wir den Einsatz von CompactPCI Serial-Systemen auch heute schon als sinnvoll.
One of the basic ideas behind the standardization of CompactPCI Serial was the possibility to continue using all existing peripheral boards and mechanical parts. This so-called ecosystem already exists, and we wanted to go on from there and not start from the beginning. Of course, we had to redesign the backplane, the bus board, because it has to comply with the new connectors and serial interfaces. In the mission-critical market, we have to supply consistent products for a very long time. Standards are so important because they allow you to develop electronic parts even at a later point in time. And this is why we played such a big part in advancing this standard.
Ganz massiv daran mitgewirkt, diesen Standard weiterzutreiben.